On this 2019 to 2024 Ram 1500DT with the 5.7HEMIGas engine, P0301 means the PCM may be seeing a cylinder 1 misfire. The truck may run rough, stumble, lose power, or turn the MIL on, and if the misfire is severe, the MIL can flash. Broadly, this can come from possible ignition, fuel delivery, air leak, engine mechanical, oiling, valve control, wiring, or PCM control issues. The PCM is watching crankshaft speed changes, and this code sets when the speed variation between cylinders exceeds a calibrated value for the current engine speed and load. If the misfire is severe, the PCM can shut off the affected cylinder's injector for a period to help protect the catalytic converter. So keep that in mind if the misfire seems to carry back to idle after a hard load event. If the truck has stop/start, that system can be disabled while this code is active. Start with the basic system checks before going into the cylinder-specific testing. Next, prove whether the condition is active. Key on, read and record the codes and the captured operating data. Drive or operate the truck under those captured conditions. Watch when the misfire shows up, and monitor the downstream oxygen sensors while it is happening. The misfire monitor needs to show excessive misfires on cylinder 1 before you stay on this path. If cylinder 1 is not misfiring now, treat it as an intermittent condition instead of forcing the test. On the oxygen sensor pattern, a reading that stays low during the misfire points you toward a lean or lack of fuel type condition. A reading that stays high points more toward excess fuel reaching the catalyst, which can happen from lack of spark or a leaking injector. Also remember that injector shutoff during a severe misfire can make a high-load misfire look like it continues at idle until the counter resets. After that, look at the other recorded codes. If there are active or pending codes in the fuel, ignition, air handling, VVT, or VVL areas, diagnose those first. If not, continue with the P0301 path. Before you judge the road test, make sure the monitor is actually allowed to run. Treat the enable criteria as a monitor gate: fuel level above 12%, battery voltage above 10. 9 volts, adaptive numerator learned, ambient temperature above -23 degrees C, -9. 4 degrees F, coolant temperature at engine start above -7 degrees C, 19. 4 degrees F, or after a colder start engine temperature reaches 21 degrees C, 69. 8 degrees F, engine speed between approximately 400 RPM and 6,200 RPM, and no decel fuel shutoff event. Then do the broad inspection. Look for anything that can disturb crankshaft speed or mixture, belt or accessory pulley drag, sensor mounting problems, connector or terminal issues at key engine sensors, throttle body, injector, coil, and PCM power or grounds, vacuum leaks, air intake or exhaust restriction, internal engine problems, moisture on ignition parts, fuel quantity or quality problems, overload or bogging conditions. If you find a problem here, repair it and verify the repair and confirm the code stays gone. If the inspection is clean, move on. With the ignition off, inspect the MDS solenoid harness connectors, jumper connectors, and terminals. You're looking for improper seating, damaged locks, corrosion, signs of water intrusion, whether seal damage if equipped, bent or pushed back terminals, overheated terminals, spread terminals, and weak terminal tension. Repair anything you find, then verify the repair and confirm the code stays gone. If those connectors pass, check the engine and intake manifold for vacuum leaks. Repair any intake leak and verify again. If no leak is found, check the fuel itself. Water, wrong fuel type, old or contaminated fuel, low fuel and proper ethanol level. If the fuel is the problem, replace the fuel and if needed, flush and clean the fuel system. Then verify the repair. Now compare injector flow on the misfiring cylinder against good cylinders. Before opening or testing the fuel system, release fuel pressure because the system can stay under constant pressure even with the engine off. Install fuel pressure decay tester 8978A at the rail. Key on. Let pressure reach maximum and stabilize, and record the starting pressure. Use the scan tool to actuate the injector for cylinder 1 while watching the gauge, then record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder, because skipping that can damage the engine. Repeat the same test on several cylinders that are not misfiring, always starting each injector test at the same starting pressure. If the ending pressures are about the same, continue. If cylinder 1 stands out, a pressure drop that is too small sends you to check for debris in the fuel rail or injector and repair as needed. A pressure drop that is too large points to a faulty or fouled injector as the issue. Then verify the repair and confirm the code stays gone. If the injector comparison does not isolate it, remove the pressure decay tester and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 1, connect the coil harness connector, disconnect the cylinder 1 fuel injector connector, install a spark tester on the coil, and crank the engine. If you have a crisp blue spark, inspect the plug and cylinder next. If you do not, move to the coil feed and control circuit checks. For the plug and cylinder inspection, shut the ignition off. Remove the cylinder 1 spark plug and look for cracks, carbon tracking, oil, coolant, or fuel fouling, incorrect gap, or a loose or broken electrode. Also check for oil or coolant in the cylinder. If those conditions are present, replace the spark plug, and if oil or coolant is in the cylinder, diagnose and repair that cause. Then verify the repair. If the plug and cylinder look okay, run a compression test on all cylinders and compare cylinder 1 to known good cylinders. If compression is not within specification, perform a cylinder leak down test to decide whether the cause is in the valvetrain or combustion chamber, repair as needed, and verify. If compression is acceptable, swap the spark plug with a known good non-misfiring cylinder, or replace it if access makes swapping impractical. Run the engine and watch the misfire monitor. If the misfire follows the plug, replace the spark plug. If the plug was replaced and the misfire is gone, the repair is complete. Then verify the repair and confirm the code stays gone. If the misfire does not follow the plug, clean carbon from the valvetrain and combustion chambers using Mopar combustion cleaner. After driving and clearing the cleaner from the engine, erase the code, road test under the captured conditions, and watch the misfire monitor. If the misfire does not return, the cleaning corrected the fault. Verify the repair. If it returns, check engine oil level and condition before going deeper. Look for mechanical tolerance issues, oil pressure out of specification, low oil level, an incorrect oil filter, dirty or deteriorated oil, contaminated oil, incorrect viscosity, or aerated oil. If any of those are present, repair the oiling or mechanical condition and verify. If not, check VCT solenoid operation. Reconnect the PCMC2 connector, key on, and measure the VCT solenoid K442 control circuit at the solenoid connector. This is a 12-0-volt PWM circuit, and the voltage needs to be present and approximately match the selected percentage. If it does not, repair the VCT solenoid driver circuit for an open or short to ground and verify. If it does, inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. Repair any issue found and verify. If no issue is found there, move to the related connector and PCM harness checks later in the path. If the earlier spark test did not show a crisp blue spark, check the ignition coil power feed first. Keep clear of the fan, belts, and pulleys anytime the engine can operate. With the ignition off, disconnect the ignition coil connector. Key on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground on the ASD relay F342 output circuit at the coil connector. If the light does not illuminate brightly, stop scan tool actuations. Repair the open or short to ground between the PDC and the ignition coil connector and verify. If it does illuminate brightly, check the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the coil connector and crank the engine for 5 seconds. If the light blinks brightly, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCM-C2 and do not probe the PCM harness connectors. Use the GPEC diagnostic adapter 10436 on the engine harness side of PCM-C2. If there is continuity between ground and the coil control circuit, repair the short to ground and verify. If the control light stayed off constantly, check for an open by measuring coil control circuit resistance between the ignition coil connector and the GPEC adapter. If resistance is not below 3.0 ohms, repair the open or high resistance and verify. If that circuit passes, or after the earlier mechanical branch reaches this same point, disconnect and inspect the PCM connectors, related inline connectors if equipped, and related component connectors. Look for seating problems, damaged locks, corrosion, water intrusion, seal damage if equipped, bent or overheated terminals, pushed-back terminals, spread terminals, and poor terminal tension. Repair anything found, reconnect everything fully, erase the code, and operate the truck under the monitor conditions. If P0301 returns after those connector and circuit checks, replace and program the PCM, then verify the repair and confirm the code stays gone. If it does not return, the wiring or poor connection problem has been repaired. The key with P0301 is to prove cylinder 1 is actively misfiring. Use the oxygen sensor and misfire data to decide whether the fault looks lean, rich, or ignition-related, and then work through fuel, spark, mechanical, valve control, and wiring in order. Don't jump to a part until the test result points there. For more diagnostic training, visit stepdiagnostics.com.